Okay, so the next topic is the biggest one in geometry, and that's triangles. משולשים. Okay. Again, just like I explained through it, it's the basics of pretty much everything else in the topic. So please know your triangle rules. I'll take the header out because I need the space. And we'll start with regular triangles. Stuff we know about any triangle in the universe. So here's number one. If it's a triangle, then let's change colors. Then if this is angle A, this is angle B, and this is angle C, I know that always A plus B plus C is 180. The sum of the angles of any triangle in the world is 180. Now let's see something else. If I extend this line and create another angle, let's look at this angle. This angle, let's call it D. What do we know about the sum of D and C? Well, they're on the same line, you can see here, so that's 180. And from that you can see that A plus B are the same as D because they both add up with the C to 180. And this is a rule. The external angle in any triangle is equal to the sum of the two non-adjacent angles, which is a long way to say this very simple thing. So just look at it. It's easier to look at this than to remember this by heart. That was number one. Number two. Here's a triangle. Again, with three angles. This is going to be angle A, and opposite to angle A, I'm going to have side A. And this is angle B. And opposite to angle B, I have side B. And this is angle C. And opposite to angle C, I've got side C. Good. So what do I know? I know that if side A is bigger than side B, which is bigger than side C, you can tell that angle A is bigger than angle B, which is bigger than angle C, and vice versa. It goes in both ways. So opposite to the big side, you will always find the big angle. That's a given. You have to know this. That was rule number two. Next, 3. Here is, again, triangle. And this is going to be side A, side B, and side C. You have to know that no matter which side you choose, let's say I choose C, any side in triangle is always smaller than the sum of the other two sides and always bigger than their positive difference. Has to be, otherwise it's not a triangle. Not every 3 sticks give you a triangle. And the last thing is the formula for the area, the inside, the area of the triangle. So the area of any triangle is area is half times the base times the height. That's G. Okay, which I usually write as half times B times height through the course times H, so you know this is much faster that way. Now I want to show you the base and the height for each kind of triangle that exists in the universe, and there's only 3 kinds of triangles. We got an acute triangle, a right triangle, and an obtuse triangle. Right triangle, all angles are right. Acute triangle, all angles are acute. Right triangle, we have one right angle, and an obtuse angle, we have one obtuse angle. So let's show you the base and the height for each. Let's start with the right. That's easy. This is the base, and this is the height, or vice versa. The two sides that give me the 90 degrees angle. Why is this doing that? Let's do just this. Okay, that works. Good. Next, for the right triangle, this is the base, and the height is always inside the triangle. You have to know that. For the obtuse triangle, this is the base, and the height is outside the triangle. So these are the things you have to know by heart. That's it. So that was regular triangles. Moving on to our next thingy, which is special triangles. So we got 3 special triangles, and here are the first 2. No, not that one. I want to talk about this one. This triangle, as you can see, has two sides which are equal. And if two sides are equal, it means that two angles are also equal, A and A. The name of this triangle is an isosceles triangle, which is a Greek word. Isosceles triangle. Two sides are equal. Good. The next one you have to know about is this one, in which all sides are equal. And if all sides are equal, all angles are equal, and they're equal to 60. Always, always, always. Good. So 60, 60, 60, and the name of this one is an equilateral triangle. Okay, so these are the triangles, two of the three we need to know, and here's the first thing we have to know about them. We have to know about them that if I take down the height, let's do this. If I bring down the height in both of these triangles, this height has two more functions. It's the height, but it's also the median, which means it cuts this side into two equal parts, so it's the height and the median, and it's also cutting this angle into two equal parts, 30 and 30 in here, and B in here, so it's also the bisector. Okay, height, median, bisector, gova, tichon, chotzer. So we have to know this about these two triangles. One last thing we have to know is that we have a specific formula for the area only of the equilateral triangle, and that is, we take the side, we square it times root 3 over 4. Trust me, this is important. This saves time. So just remember side 2, 3, 4, side 2, 3, 4. It's like a morning workout. And that way we can save a lot of time when we practice, when we do questions about equilaterals. And they do ask about this quite often. So these are two of the three triangles you need to know. Let's talk about the third and probably one of the most important triangles we need to talk about, and that's the right triangle. So here is the right triangle. What do we need to know? First, names. We have to know that each one of these is called a leg of the triangle, and then the third side, the big side, big because it's opposite to the 90, is called the hypotenuse. Hypotenuse. Okay, yeter. So that's names, but that's not that important. Next, let's erase this. Okay, went a bit too far with that erasing thingy. So let's erase it. Let's draw the triangle again. And here's the triangle. You know, here's the sentence you know already, the theorem. If this is A and this is B and this is C, you have to know that A squared plus B squared is C squared. This is the Pythagoras theorem. Cool. However, this takes forever in the test. You don't want to do that. So what you want to do is remember the recycled quadratic, triangles, which are the 3, 4, 5 triangle and the 5, 12, 13 triangle. And I'll show you tips about how to remember this in a second. More importantly, what is this good for? It tells me that if two sides of a right triangle are 3 and 4, I can find the third one, which is 5. Okay? And not only that, I can also see that if, for example, a triangle has two sides which are 30 and 40, the hypotenuse must be, 50, because it's not just a specific triangle, it's a ratio. So keep that in mind. This can save you a lot of time in calculation. They know you know this, so they want to ask questions about this, assuming you know this. They can give you like really hard numbers, like 500, 120, and 1200. And if you don't remember that the last slide is 1300, it's going to take you forever to calculate that one. So remember these triangles, these triplets by heart. So this was the right triangle, and now we're moving on to one before last topic in triangles, which is special right triangle. There's just two of them. So here's the first one. And this is the right isosceles triangle. It's a right triangle with two legs which are equal. What do we have to know? We have to know that the ratio between the sides of this triangle is always the same. It's always x, x, and x root 2. I have to know this. I have to know that to get from the small to the big, I multiply by root 2. And to get back, I will divide by root 2. That's it. You're going to see a lot of this, so if you choose not to remember this, you're going to waste a lot of time with this. Remember that root 2 is approximately 1.4. That's the first of the special right triangles. And the second one is this one. It's the 90, 30, no. It's the 90, 30, 60 triangle. Again, what's so special about these triangles? Nothing. They just keep asking about them, so knowing them saves time. And again, the ratio is constant. The small side, small opposite the 30, yes, is x. The big side, opposite the 90, is 2x. And the medium side is root 3x. Let's remember that I go back and forth between the small and the big side by multiplying and dividing by 2. And I go between the medium and the small side by dividing and multiplying by root 3. Also, I have to know that root 3 is approximately 1.7, which really helps in approximations. Good. So please choose to know these things by heart because they will ask about this a lot. Okay. Moving on. Here's the last thing we have to know about, talk about, which is triangle similarity. So I'm drawing two similar triangles. What's similar about them? All of their angles are equal. So A and B, and C and C. You can see that they're not the same thing. They're not the same triangle. They're like the same thing, only zoomed in, only bigger. What do I have to know? I have to know that similar triangles, again, triangles that have the same angles exactly, maintain the same linear ratio, which means if this is a 2 and this is a 4, I know that everything in this, every line in this triangle, the big one, is twice as big than every line in the small triangle. So 4 and 2, and then, for example, 10, which means this must be 5. And if this is, for example, x, then this one must be 2x. Okay, that wasn't that hard, but here are a few sketches that imply similar triangles. So if you see these upcoming few sketches, know that the topic of the question is probably similar triangles, going from most common to most seldomly seen. The most common one of the shapes you have to know is this one. It's a triangle with a parallel line inside. Why? Because now you can see that this angle is common to both this big and the small triangle, and this angle is equal to this one, and this one is equal to this one. So I got two triangles, the small and the big, which are similar. Okay, that's number one. Number two, if I'll ever get there, here we go, is sand clocks or bow ties. What that? What? Here we go. As long as these sides are parallel. If they are parallel, I got two similar triangles. Just be aware and to the fact that this side is similar to this side. Okay, it's like flipped. I got two similar shapes again. And the last one, which is not very common, but also the hardest one to spot, is this. I got a right triangle, and with the perpendicular to the hypotenuse. So let's see what we get. This is A. This is A. Here we go. This is A, and this is B, and this is 90. So this is also B, and this is also A. So this time I got three similar triangles. The big one is similar to each one of the small ones. And a word of advice about all of these, if you see that, what's going on here, if you see that, all you have to do is draw them apart so you can see the similarity. Okay, so please know all of this. This is very, very important. You will see a lot of this in the test. Next comes quadrilaterals.